Hey everyone, glad you're here. And listen closely, because the next few seconds might change the way you think about what drifts through our solar system. Imagine looking at a distant object from another star system and realizing almost instantly that something about it refuses to behave like nature intended. That's exactly what happened the moment astronomers captured the first clear images of 3I Atlas. The picture looked ordinary at first, a faint blur, a few streaks of light, until the observers zoomed in and saw jets stretching across space like rigid beams, locked in place with a precision that shouldn't exist on a spinning object. For anyone paying attention, it felt like the universe had just whispered, "Something's off, look again." Those early shots came from a 0.2-meter telescope in New Mexico. Nothing massive, nothing exotic, just a dedicated astrophotographer trying to catch a better view. But the moment he released his composite, other observers scrambled to confirm what he'd found. The jets extended in multiple directions, perfectly linear, almost impossibly stable. And that's the part that grabbed scientists by the throat. The object was rotating, not slowly, not ambiguously, but on a tightly measured 16-hour cycle. Over the distance those jets traveled nearly 1 million kilometers, the object should have twisted dozens of times. Yet the jets held their aim, as if the source wasn't turning at all. What followed was a rush of confirmations from observatories around the world, each one reinforcing the same unnerving detail. This wasn't distortion, it wasn't a trick of perspective, and it definitely wasn't an imaging glitch. The jets appeared frozen, while the body beneath them spun. And instantly, researchers realized they weren't dealing with a simple curiosity. They were facing something that contradicted the physics they trusted every single day. When a rotating object vents gas, the trails smear outward, spiral, bend, or break into segments. That's standard, that's predictable. But here, none of the expected behavior showed up. The straightness became the first signal that 3I Atlas wasn't interested in following rules. It was announcing its own. And for many astronomers, that was the moment the mystery began to feel real. As the investigation deepened, the strangeness only stacked higher. Observers reviewing earlier data noticed something unsettling. These frozen jets weren't a one-night fluke. They'd appeared in multiple exposures across different nights, with different equipment, under different atmospheric conditions. The consistency should have reassured them instead. It made the whole thing even stranger. Natural objects don't perform with that kind of precision. They drift, wobble, flare, fade. But this thing? It held steady. And the people studying it couldn't help wondering what kind of force or structure could maintain that level of exactness across a spinning body drifting through sunlight and solar wind. Later, as more data poured in, scientists began stitching together the earlier anomalies that had already made 3I Atlas a statistical outlier. Everything from its bizarre composition to its retrograde arrival path hinted that this object didn't come from anything resembling a typical birthplace. Its timing, its brightness, even the odd way it fired material toward the sun, all of it painted a picture that shouldn't exist. Yet none of those earlier quirks prepared researchers for the way the jets refused to acknowledge rotation. If the surface was turning, why wasn't the gas turning with it? Why weren't the beams sweeping across space like the beam of a lighthouse? Observers ran calculations again and again, trying to catch an error, a simple oversight, anything that would bring the object back into the familiar world of natural behavior. But every check led to the same conclusion. The data wasn't wrong. Something else was. That's when the theories started falling apart. Slowed rotation? Impossible, the physics works the opposite way. Shadowed cavities pulsing once per spin? The jets should have shown gaps, and they didn't. Fragmentation? The nucleus was intact. As each explanation failed, researchers were pushed closer to a line they didn't want to cross, the idea that this might not be a simple piece of cosmic debris. Some speculated cautiously, insisting that if the cause is natural, it must involve processes we've never seen before. Others whispered that the precision looked eerily similar to engineered control, like the automatic stabilization a spacecraft uses to counteract its own rotation. No one claimed it outright, but the comparison hung in the air. Now it's your turn. What do you think 3I Atlas is actually doing out there? Drop your thoughts in the comments. I want to hear your take on this mystery. The deeper astronomers dug into the behavior of 3I Atlas, the more the puzzle tightened around a single uncomfortable truth. Every natural explanation sounded reasonable until it touched the actual data, and then it collapsed. The rotation rate was rock solid. 7 independent telescopes confirmed the same 16.16-hour period across weeks, leaving no room for the usual excuses about measurement noise. But the jets behaved as if the object wasn't rotating at all. And that contradiction pushed scientists into territory where instinct and training pulled in opposite directions. On one hand, physics says a spinning body can't produce perfectly aligned beams for a full month of outflow. On the other, the images clearly showed those beams holding steady across astronomical distances. It was like trying to reconcile two realities that refused to meet in the middle. Researchers tried turning the problem inside out. If the gas moved for a month before becoming visible, then 3I Atlas should have completed roughly 45 full rotations in that time. 45. That alone should have shredded the jets into broad fans sweeping across space, yet every structure remained so straight it looked machine-drawn. Observers compared the object's behavior to comets with known rotation periods, hoping to see some faint parallel. Nothing matched. Those comets showed smeared arcs, spirals, even jagged interruptions as vents turned toward and away from the sun. But this object? No curvature, no breaks, no evolution, just frozen lines. One astronomer described it quietly as too clean, and others knew exactly what he meant. Nature rarely draws with perfect precision. It lets things wander, drift, distort. And yet the longer scientists stared at the data, the more they realized the jets weren't wandering at all. They were holding their positions as if locked by an unseen mechanism, echoing a level of stability that simply shouldn't exist in a body being spun by its own momentum through interstellar space. The moment researchers began reviewing the long list of earlier anomalies, they found themselves in even stranger territory. 3I Atlas had already broken expectations before the jet mystery even surfaced, and each anomaly seemed to stack onto the last like a series of cosmic warning shots. There was the retrograde arrival trajectory threaded through the ecliptic plane with uncanny precision, something observers said was statistically tiny. There was the bizarre nickel-heavy composition, so extreme that it resembled processed alloys more than cosmic randomness, stirring rumors that the material might have come from some ancient industrial environment. And then the object's wild brightness, its rapid color shift, its unreasonably low water content, each feature chipped away at the idea that this was just another interstellar wanderer. But the most unsettling piece was how all these traits combined into a single profile that shouldn't occur naturally. Probabilities stacked into absurdity. Coincidences became patterns. And once scientists added the frozen jets to the list, the entire narrative tilted into a place where the familiar rules of astrophysics felt strangely insufficient. Some researchers insisted that a natural explanation must exist, one buried deep in exotic chemistry or unknown internal structures. But others admitted, with cautious language, that the behavior reminded them of something engineered, the way spacecraft use controlled thrust to counteract their own rotation. No one wanted to jump to conclusions, yet the resemblance lingered like a shadow no one wanted to name. The final question hanging over 3I Atlas is the one scientists hesitate to ask out loud. What does this object represent? Is it showing us physics operating at the very edge of our understanding? Or is it an example of something crafted, something ancient, precise, and running on principles we haven't discovered yet? Observatories continue to gather data, scanning for rhythmic signals, analyzing jet chemistry, and searching for any clue that might bridge the impossible gap between rotation and those unwavering beams. But the truth remains suspended. The object keeps drifting, the jets stay impossibly straight, and the contradiction refuses to resolve itself. And maybe that's the part that feels the most profound, the idea that something out there is quietly demonstrating a form of order we didn't expect to encounter in the cold emptiness between stars. Whether the explanation turns out to be groundbreaking physics or something far more deliberate, 3I Atlas has already pushed us to reconsider the limits we assume the universe follows. And until we uncover the answer, we're left standing in the dark, staring at a frozen line drawn across millions of kilometers, daring us to understand how it holds together. Tell me what you think this object really is. Drop your theory in the comments.